interactive business intelligence web app using LLM-based natural language queries on a Kimball-dimensional sales data warehouse. This research project focuses on developing an interactive, user-friendly web application to convert natural language to SQL and allow people with like very less knowledge or no technical know-how on SQL to get information from a sales data warehouse using natural language. So this is the high-level overview of the web application. So basically there's a user who will be accessing the web application through a web browser. So this web app will be hosted on cloud, and so the backend of the web application will be connected to the sales data warehouse again, which will be hosted on cloud, and also the latest and most advanced models, LLM models provided by OpenAI, Anthropic, and Gemini at the time of development. So basically what happens is the user will be asking a natural language question from the web app, and the web app will be sharing this natural language question along with the schema information of the sales data warehouse with the selected LLM. So the user can select what is the preferred LLM model they will be using for this natural language question. And the LLM model will be generating a SQL query based on the request. And once the web app receives the SQL query, it will execute the SQL query against the sales data warehouse, and the result which is returned from the query along with the SQL query generated will be displayed in the dashboard of the web app to the user. So when looking at the architecture diagram of this web app, so basically the data platform, the ETL pipelines, and the data lakehouse will be hosted on Databricks, and a GitHub repository will be used for the version controlling of this data platform code base. And the front end and back end of the web application will be hosted on an AWS EC2 instance, and different secrets related to this like the credentials, API keys for LLMs will be stored in AWS Secret Manager. And basically both the web backend and web frontend separate GitHub repositories will be used for version control. The web backend will be developed using Python and Flask web framework, while the web frontend will be developed using HTML, CSS, and JavaScript. So the web frontend will be accessed via a web browser since it's hosted on cloud and publicly accessible. So it will be accessible to anyone with the link for the EC2 instance. And as LLMs, the latest models provided by OpenAI, Anthropic, and Gemini will be used. And to test the backend APIs provided by the web backend, Postman will be used. So basically, if we go through the scenario, initially the user will be asking an ML question from the web frontend and will be providing, like selecting what is the preferred large language model. So this the web frontend will be calling the endpoint using a REST API call and calling the web backend. And so the backend will receive the ML question and the selected LLM from the frontend API call. And so based on the selected LLM, the schema information of the data warehouse along with the ML question will be passed to the large language model, and a SQL query will be generated. This SQL query will be executed against the sales data warehouse hosted as a data lakehouse on Databricks platform, and the results retrieved from the SQL query along with the SQL query will be passed to the web frontend and will be displayed to the user. So this is the Kimball dimensional model for the sales data warehouse, which will be hosted as a data lakehouse on the Databricks platform. So this has a centralized goal sales fact table, and the customer dimension, store dimension, product dimension, and currency dimension tables, along with category and country state sub-dimension tables. So this follows a Snowflake schema architecture. So the sales data warehouse will be hosted as a data lakehouse on the Databricks platform. So here basically there will be this repository to host the code base for the ETL jobs, DDL scripts and everything. So GitHub repository will be used for version control. And basically, so there will be this bronze, gold and silver layer folder structure to host the DDL scripts, ETL jobs under each layer. And so this will be the Unity catalog. So there will be separate tables for bronze, gold and silver layers. And so basically the ETL job is this. So there will be like a ETL scheduler to run the bronze layer, silver layer and gold layer ETL jobs on like proper order with following all the dependencies. And finally it is the gold ETL row. And finally, so going to the compute section, there will be a serverless starter warehouse used as the compute. So the front end and the back end of the web application will be hosted using AWS. So basically the secrets manager on AWS will be used to store credentials like API keys and credentials for the data warehouse. And an AWS EC2 instance will be used to host both the front end and the back end of the web application. And moving on, so the research, the front end of the front end repository is this, and let's SSH to the EC2 instance. Let's go to the location where we can see the front end code base on the EC2 instance. So here you can see the code base for the front end, and now we can go to access the front end of the web application. So you can see the front end of the web application here, and it can be accessed using the public IP version for address of the AWS EC2 instance. And so this is the code base for the backend of the web application. And now let's go to the location for the backend code base in the AWS EC2 instance. So here you can see the code base for the backend, and as the next step, let's try to run the backend of the web application using this Python command. So now the backend of the web application is running. Now let's do a demonstration on how these NL questions are asked and how the results are retrieved. So we can access this web frontend using the public IP address of the EC2 instance. And here we can ask any NL question related to the data warehouse, and we can select the preferred LLM, and the web app will be returning as output what was the selected LLM, what is the SQL query for that NL question, and the result data set from the sales data warehouse. So I'll be asking the same NL question from the three available LLM models, and let's compare their output. For an NL question, so in this case the NL question is how many total orders came from male versus female customers in 2020. So for any NL question, a gold SQL query will be formulated, and the components of the gold SQL query will be listed. So here it is: select, count, distinct, from, join, where, and group by. And also this NL question will be provided for all three LLM models used, and the generated SQL query will be extracted. So the SQL query generated by each LLM will be compared against the gold SQL query based on each component. So all the components will be compared, and for an exact component match, the binary score will be 1, and otherwise it will be 0. And this scoring will be done for all the components. And finally, this mentioned formula will be used to calculate the query accuracy score for a generated SQL query by the selected LLM. 17 NL questions were prepared so that it covers all the relationships in the Snowflake schema of the sales data warehouse, and each of these NL questions will be provided to all three LLM models used, and the output query generated for each question will be scored based on the formula in the previous slide. And after calculating all these scores, the average accuracy across all 17 NL questions will be calculated for each LLM using the formula shown in this slide. And the average accuracies across all NL questions derived are as follows. For OpenAI GPT-5, it is 95.74%. Google Gemini 2.5 Pro, it is 95.88%. And Anthropic Claude Opus 4.1, it is 89.13%. And the most important outcome and mention in this is that in most cases, it generated the exact output we needed for the NL question, and in some question it was like partially correct. So there were like very less, there were like almost no occasions which it was completely incorrect. So the take is that when we ask the question, if we don't get the desired answer in a very rare case, we can we can give more information through the NL question and get a more accurate answer. So this web app can be developed further using prompt engineering and making a more optimized prompt to get more accurate answers and increased accuracy.